It is the single most important material of the modern age. Skyscrapers stand because of it. Cars, ships, bridges, railways, tools, and machines are built from it. We produce nearly 2 billion tons of it every single year, more than any other metal on Earth by far. And yet it begins as something humble and unremarkable. Reddish rock dug out of the ground. To transform that rock into steel, we melt it in furnaces hotter than a volcano, blast it with pure oxygen, and pour it out in glowing rivers of liquid fire. It's one of the most dramatic manufacturing processes on the planet. So how do we turn dull red ore into the strong, gleaming metal that holds up the modern world? Today we're going inside the mill to find out. Humans have worked iron for over 3,000 years. The Iron Age transformed weapons, tools, and farming. But true steel, iron's stronger cousin, was for most of history rare and fantastically expensive, made in tiny batches by skilled smiths. That changed in 1856, when an Englishman named Henry Bessemer unveiled a revolutionary idea. He discovered that blasting air through molten iron would burn away its impurities and almost magically turn it into steel, quickly and in huge quantities. The Bessemer process slashed the price of steel dramatically, and the world was never the same. Suddenly, steel was cheap enough to build railroads across continents, bridges across rivers, and towers into the sky. The age of steel had begun, and modern civilization was built on top of it. So what exactly is steel? At its core, steel is beautifully simple. It's iron, mixed with a tiny amount of carbon, usually less than 2%. That may not sound like much, but that pinch of carbon changes everything. Pure iron on its own is actually quite soft and bends easily. But add just a little carbon, and the carbon atoms wedge themselves between the iron atoms, locking them in place and making the metal dramatically harder and stronger. Too little carbon and the steel is soft. Too much and it becomes brittle and cracks. The entire art of steelmaking is really about control, carefully managing that carbon content along with other ingredients to get exactly the properties you want. And it all starts deep underground. Steel begins with 3 raw materials. The first and most important is iron ore, rock that is rich in iron oxide, usually a reddish mineral mined in enormous open pits around the world. But iron ore is stubborn. The iron inside it is chemically bonded to oxygen, and stripping that oxygen away requires help. That's where the second ingredient comes in, coke. Not the drink. This coke is a form of purified coal, baked until it's almost pure carbon. Coke is both the fuel and the chemical key that pulls the oxygen out of the ore. The third ingredient is limestone, which acts as a cleanser, absorbing dirt and impurities so they can be removed. Iron ore, coke, and limestone. Together, they're about to meet an inferno. The heart of traditional steelmaking is a towering structure called the blast furnace, a giant chimney of fire that can stand 10 stories tall and runs continuously for years. From the top, iron ore, coke, and limestone are loaded in layers. From the bottom, superheated air, over 1,000 degrees Celsius, is blasted upward. As the coke burns, it generates ferocious heat and strips the oxygen away from the iron ore. The iron melts, trickling down as a white-hot liquid to pool at the base of the furnace. The impurities combine with the limestone and float on top as a layer of waste called slag, which is skimmed off. What's tapped from the bottom is molten iron, but it's not steel yet. It still has far too much carbon, and it's about to be purified by fire and oxygen. The molten iron from the blast furnace, now called pig iron, contains around 4% carbon, far too much. To turn it into steel, that carbon has to come down. This happens in a giant vessel called the basic oxygen furnace. Molten pig iron is poured in, often along with recycled steel scrap. Then a water-cooled lance descends, and blasts pure oxygen down onto the molten metal at supersonic speed. The oxygen reacts violently with the excess carbon, burning it off as gas in a spectacular shower of sparks and flame. In just 20 minutes or so, a single furnace can convert hundreds of tons of iron into steel. The temperature, chemistry, and timing are controlled with incredible precision. When it's done, the carbon has dropped to just the right level, and molten pig iron has become molten steel. But there's a second, increasingly popular way to make steel, one that skips the mines and the blast furnace entirely. It's called the electric arc furnace, and its main ingredient is simply recycled steel. Scrap steel, old cars, appliances, beams, and cans, is loaded into a massive furnace. Then enormous graphite electrodes descend and unleash powerful electric arcs, bolts of man-made lightning that can reach 3,000 degrees Celsius. The scrap melts into a glowing pool of liquid steel. This is possible because of one of steel's most remarkable properties. It is infinitely recyclable, meltable, and reusable over and over with no loss of quality. In fact, steel is the most recycled material on the entire planet. More is recycled each year than paper, plastic, glass, and aluminum combined. However it's made, the result is the same: a vast quantity of molten steel, glowing orange and ready to be shaped. But you can't build with a liquid. It has to be solidified. For most of history, steel was poured into individual molds called ingots, then reheated later. Today, nearly all steel is made solid through a faster, continuous method called continuous casting. The molten steel is poured into the top of a water-cooled mold, where its outer shell begins to harden. It's then pulled steadily downward as a glowing, semi-solid strand, cooled by sprays of water as it goes. By the time it emerges, it's a solid, red-hot bar of steel, which is cut to length by torches. Depending on the mold, this produces thick slabs, square blooms, or smaller billets, the raw building blocks for everything that comes next. Those slabs and billets of solid steel are still just crude blocks. To become useful products, they need to be shaped, and that's done by rolling. The steel, reheated until it glows, is passed back and forth through a series of massive rollers that squeeze and stretch it, exactly like a baker flattening dough. A thick slab can be rolled thinner and thinner until it becomes a coil of sheet steel, just millimeters thick, destined for car bodies and appliances. Other rollers are shaped to form the steel into I-beams for construction, rails for railways, rods, bars, and wire. Some steel is hot rolled while glowing. Other steel is cold rolled at room temperature for a smoother, stronger, more precise finish. From a single glowing block, steel can be transformed into almost any shape imaginable. So far, we've been talking about basic carbon steel, but by adding other elements, steel makers can create alloys with astonishing properties. Add chromium, and you get one of the most famous of all, stainless steel. Its invention was something of a happy accident. In 1913, an English metallurgist named Harry Brearley was trying to make better gun barrels. He added chromium to steel, and later noticed that while his other experimental samples had rusted, this one remained bright and untarnished. The chromium had formed an invisible, self-healing layer that protected the steel from corrosion. That rust-proof metal became stainless steel, and today it's in everything from cutlery and kitchen sinks to surgical tools and skyscraper spires. Other alloys add nickel, manganese, or tungsten to make steel tougher, springier, or able to survive extreme heat. There's one more trick that gives steel its final character: heat treatment. The same piece of steel can be made soft and bendable, or hard enough to cut other metal, just by heating and cooling it in different ways. To harden steel, it's heated until glowing, then plunged suddenly into water or oil, a process called quenching. The rapid cooling locks the steel's internal structure into a hard, rigid state. But fully hardened steel can be brittle, so it's often gently reheated in a step called tempering, which trades a little hardness for toughness and flexibility. This is the ancient secret behind a good sword or knife blade. And today, the same principles harden everything from drill bits and gears to the springs in your car. Control the heat, and you control the metal. So why steel above all other materials? The answer is a rare combination of qualities. Steel is incredibly strong, yet it can be shaped, bent, welded, and machined with relative ease. It's abundant. Iron is one of the most common elements on Earth. It's cheap to produce at massive scale. It can be made soft or hard, flexible or rigid, plain or rust-proof, simply by tweaking the recipe. And when a steel object finally reaches the end of its life, it isn't wasted. It's melted down and reborn as something new. No other material matches that blend of strength, versatility, affordability, and recyclability. It is, quite literally, the skeleton of the modern world, hidden inside the walls, roads, and machines all around you. Before we finish, here are a few staggering facts about steel. Every year, the world produces roughly 1.9 billion tons of it. That's over 200 kilograms for every person alive. A single country, China, makes more than half of all the steel on Earth. The tallest buildings, longest bridges, and biggest ships would be impossible without it. And remember that recyclability. A steel beam in a demolished building might be melted down and reborn as a car, which decades later becomes a kitchen appliance. The same iron atoms, endlessly reused. From a lump of red rock to the gleaming frame of a skyscraper, steel is the quiet, colossal foundation beneath modern life. And now you know exactly how it's made. So the next time you cross a bridge, ride in a car, or look up at a towering skyline, take a moment to think about the incredible journey of the steel holding it all together. From ore in the earth, through furnaces of fire, into the strong and endlessly reusable metal that built our world. If you enjoyed this video, subscribe. We break down how everyday things are made every single week. And drop a comment below. Which material or machine should we melt down and explore next? Thanks for watching, and we'll see you in the next one.